An offshore oil well, P, is located in the ocean 5 kilometers from the nearest point on the shore, A. A pipeline is to be built to take oil from P to a refinery that is 20 kilometers along the straight shoreline from A. If it cost $100,000 per kilometer to lay the pipe underwater, then only $75,000 per kilometer to lay the pipe on land, what route from the well to the refinery will be the cheapest? First, start out by drawing a diagram. Here's our diagram with the oil wells P and the refinery over here. Start off by drawing a point P, A, and one over here. Draw a triangle with two sides from P to A and A to here, making this side X. With the triangle you have created, use the Pythagorean theorem to find your distance in water. A squared plus b squared equals c squared is your Pythagorean theorem. Therefore, it would be x squared plus 5 squared equals your distance in water squared, which means that the square root of x squared plus 5 squared will equal your distance in water. Now, you have to come up with a cost formula. Do this by multiplying your distance of water multiplied by your price of water piping plus your distance of land multiplied by your price of land piping. Next, you fill in your values. Your distance of water value goes in here, and your distance of land value goes in here. After that, switch your square root sign to an exponent of 1/2, followed by simplifying your brackets on this side. Now you have to differentiate your cost formula by using the power rule in your first bracket and the constant rule in your second bracket. You do this by bringing the 1/2 down and multiplying it with your coefficient and subtracting 1 from your exponent, and then differentiating inside the brackets. And the constant rule allows this to stay 75,000. Next, you have to set C prime to 0. So you have 0 equals 50,000 times 25 plus x squared to the negative 1/2 times 2x minus 75,000. After that, you will add 75,000 to both sides. After having done that, you'll bring the 25 plus x squared to the 1/2 to the bottom and multiplying both sides by each denominator, which will give you 75,000 times 25 plus x squared to the 1/2 equals 100,000x.
Next, square all of the terms on both sides of the equation. This will get rid of the power to the 1/2. With this answer, multiply through the brackets this term with 25 plus x squared. You're going to get some really big numbers. Next, subtract this term from both sides of the equation. After that, you're going to divide the coefficient on both sides of the equation. This will leave you with x squared equals 32.14. Square root both sides of the equation to get rid of the squared. This will leave you with x equals the square root of 32.14. Simplifying, x equals 5.67. Therefore, the pipe in the water should touch land 5.67 kilometers from point A. It will continue on land for 14.33 kilometers.